Okay, so this problem says a conical water tank is leaking from the bottom or its point. The tank is 100 feet tall and has a diameter of 50 feet. The radius of the circle at the water surface is changing at a rate of 2 feet per day. At what rate is the volume of the water changing at the time when the radius of the surface of the water is 5 feet, 15 feet, whatever. Okay, so what is the first thing we're going to do for this?
Draw a picture.
Draw a picture. A conical is a cone.
If we draw it big or small.
It doesn't matter. I would draw it. So conical is a cone. What information do I have about this cone? The diameter is 50 feet, which means all the way across the top is 50 feet. Which means my radius is what? Just out of curiosity. Good. Make sure you guys can do that basic math. What else do I know about this specific tank? It's 100 feet tall. Oh, I did. What else do I know about it? It's leaking, which means what is changing?
Why are they not putting water back in it? What is this tank used for?
I don't know. That is not any of my business.
Volume.
Well, it doesn't tell me anything about the volume change. So what does it tell me about? What change? Nope.
Actually,
Surface.
the
The radius. The radius is changing at what rate? 2 feet per day. So that's our DRDT.
Why is the radius?
What I don't like is how it's leaking, but it stops leaking a little bit every day. Why can't it just leak the same? I would at least think it would leak faster towards the end. No, it would leak slower, wouldn't it? It would have less water pushing out. I figured the water pressure wouldn't matter too much in that small.
Maybe it does. There are a lot of unknown factors here.
This is not chemistry.
That would be physics, actually.
Whoa, Corbin, Jesus
Yeah.
Christ.
Oh my gosh.
Corbin's in there,
I like it.
It's fun.
What was that noise there?
I do have a question for you though. Is this change increasing my radius or decreasing my radius? Decreasing. So it should be a -2 feet per day.
I just realized it's because it's a cone.
Good job, Erin.
That's why it's decreasing.
Ooh. Well, decreasing because it's leaking water.
Well, yeah, but it's an account. So
That works.
Oh, you're so amazing.
That works. Huh?
The 15.
We'll get there in a second. No, kind of. Okay. So I'm going to go ahead and draw an alternative picture that's going to help us kind of see this in a different way. So instead of looking at the entire cone, I'm just going to look at the right triangle created by the height, the radius, and the sides of my conical tank. Filling in the information I already have, I know that on the original tank it's 100 feet, and my radius is 25. We're all okay with that, right? So I just took a slice out of this essentially and cut it in half. But I also have information about when the water level is at a different height, right?
We want to find information about.
Right. So that is technically a different triangle here. So we have a different height of water, which correlates to a different radius of the tank that I'm looking at. I know on this specific, I don't know, depth of water, I'm looking at a radius of 15 feet, and I'm solving for the change of the volume at that specific radius, which means I have to know the height at that radius as well. What do these two look like to you?
So different sizes.
So similar right triangles, because they're both right triangles, and it's out of the same conical shape, which means that their sides are always proportional to each other. So I can actually use a fraction. Remember how I set it up in my notes? So the height of my original over the height of my new is equal to the radius of my original over the radius of my new. And I say new loosely. I'm saying new to indicate the different water level that I'm looking at. And I'm going to use this information to solve for my height h for this particular water level.
How is the triangle just a different way to look at it?
Yes, it's kind of taking out the three-dimensional aspect, which makes it easier to identify sides and lengths and whatnot.
I was like, why are you
So now we're just going to go ahead and cross multiply. And when I do, I get 1,500 equals 25h. I can solve for h by doing what? Dividing, and what do I get? 60. Everyone okay with what we did there?
Yeah. The answer?
Semi.
No.
If only.
The answer I'm trying to solve for is the rate at which the volume is changing. So that's dV dt, in case you didn't write that down somewhere. That's what we're solving for. Which means I'm going to need an equation to do this with. So if if I'm solving for where the volume is changing, what equation do you think we're going to need?
Volume.
The volume of a cone. Anybody know what it is?
1/3 higher squared height. It's like the height.
There's just a lot going on right there, isn't there?
1/3 higher squared height.
I know circumference.
It's like 1/3 of what the cylinder would be.
It is. So 1/3 pi r squared times the height.
See, this is why. So that's the
This is the equation or formula that we're starting
is
with.
that dV?
Neither. This is just v.
But we're fall.
When I take the derivative, it will be d. Yes. I can't take the derivative, though, until I have only one variable left on that right-hand side, because that's going to be the easiest.
So which h?
Anybody have an idea of how we could replace that h with something in terms of r? Because right now it has an exponent on it, which would make it a lot harder to work with.
Wait, isn't height? We found the height, right?
I found the height of this specific triangle, but I want to derive it before I do anything else.
Oh,
Put it in front.
Okay, so my height is 60. What's the radius of my circle? Or the radius of my cone at that point? 15. 15 times what equals 60? 4. So I could also write 60 as 4r instead of actually having a 60. This allows me to replace the h.
So how did we get there again?
60 and 15, I just looked at the relationship and recognized that 15 times 4 equals 60. So 4 times 15 is 60, and I just replaced the 15 with my r because that's the radius of the specific height.
you can't just put a 60 in.
No, we don't want to do that.
Okay.
So now I have 1/3 pi r squared times 4r. Of course, I can simplify this a little bit more, leaving me with 1/3 times 4 pi r cubed, because I multiplied the 4 in and the r in. And then, of course, I could simplify it more and make it 4/3 pi r cubed. And then what am I going to do? Differentiate.
Oh my gosh, what the heck?
So now I have dV dr equals, I drop the 3 down and I'm left with 4 pi r squared and then dr dt.
No, that's the same.
Do we know our dV?
Yeah, dV dr is the same as dV dt. And now I can just fill in any information that I have. Specifically, I know dr dt and I know r. And that will allow me to solve for dV dt. So go ahead and fill in that information and solve for the change in volume. Yeah, we do know R. What's my R here at the specific water height? 15. And then what's my dr dt? -2. Change in my radius per day.
Is it -2?
Yes, it was -2.
I get that count.
Very, very small numbers.
What'd you get, Deanna?
-5,654.866.
What's my label? Feet cubed per day. Yes.
I lost my count.
That is an approximation, yeah, because I rounded the decimal. If you put equal, though, I would still count it. So we got -5,654.8668 feet cubed per day. I know it's cubed because it's volume, and volume always has units cubed. And I know it's per day because that was the other rate change in the problem. Questions, concerns, or issues with that?
I got -1,800 pi.
We'll multiply the pi in.
Oh, okay.
Questions, concerns, or issues with that? Yes. Okay, go ahead and work with each other to do the homework problems.
So just get it done. Now let's go ahead and do the first one. What the H is a constant.
Liam, get back here.
I can tell you.